Hi, this video is about tangents to circles. Now, what we're going to look at today is, first of all, what a tangent is. Okay? So in the context of circles, a tangent is a line that touches the circle at just one point. So we've been used to chords, which cut through the circle. We've got diameters and we've got radii. Tangents is a different type of line that interacts with the circle, and it only touches the edge of the circle at one point. So I'll show you that just now. Okay, so make sure you're copying that into your jotter. A tangent is a line that touches the circle at one point, and then what we're going to do is we're going to look at this diagram here and we're going to kind of identify the different pieces on it that are going to help us to figure out missing angles and so on. Okay, so first thing we can identify is this line here. So this is what we're talking about. A tangent is a line here and it touches the circle just at one point. So it comes past the circle and just touches the edge of it. Okay, so if we draw out this diagram, if you want to pause me just now and copy this diagram into your notes jotter, and then we're going to put the labels of the things on it together. Okay, so this here is our tangent. So that's the tangent, alright? And this line here goes from the centre of the circle to the edge of the circle. We know that that is called the radius. And the important thing to notice here is when the radius and the tangent meet, we get a special kind of angle. Okay, we get a right angle. So we can mark that in here like so. Now, this always happens, right? So when a radius and a tangent intersect, you always get a right angle. Okay, so we're going to write that down as well. All right. So we're going to write when radius and tangent, and we'll use a fancy math word, we'll say intersect, on the circumference of a circle a right angle. As formed, okay, and that's going to be a kind of way in for us to work out lots of different problems to do with angles and lengths and so on with circles and tangents. Okay, so we can see here that we've already got 25 degrees in here, right? So let's say, for example, that the question had asked us to work out the size of angle AOB. Alright, so angle AOB, what is that? Right, so AOB, remember you trace it with your finger and that gives you the angle, so it's going to be this angle here. Now, we know that this 90 and the 25 and that angle must add up to 180 degrees. So, therefore, if we do 90 take away 25, which gives us 65, so 90 take away 25 equals 65 degrees. Because remember, we were talking before about how these two angles, the two acute angles in a right angle triangle, will always add to 90 as well, right? So that's really important. So, because of the fact that we know, okay, so remember, in the first instance, you will not be given this, right? You will have to know this fact and then know that that's a right angle, okay? I've just drawn it in because we should always draw it in the diagrams to help ourselves, okay? So this is a 90 degree angle, this is 25, so that must be 65 degrees. Okay, so that's how we work out, excuse me, a missing angle when we have a tangent which forms a right angle triangle with a radius. So we've got the radius and the tangent forming the right angle, and then we've got our hypotenuse here of a right angle triangle which joins these two up. We're forming a right angle triangle, as you can see, and we can therefore work out the size of that angle there. Okay?